Hi, my name is Leder Fakinetti, and let's write some code together, shall we? What we have on the menu today is to continue working on this library for JSFX that's going to allow you to have better looking JSFX and possibly easier to use and hopefully easier to develop. So if you were here last Friday, I was doing a bunch of refactorings and I was transforming the values, or I was transforming the design options in the design system, things like what colors you can have in the layout. I was transforming that into values. Then after the stream, I was thinking about it and I thought, well, this is really only useful if you are trying to do this sort of thing that you see on the screen right here, where I'm showing you all the different colors you could have. And everyone would have to pay the price of this dynamic lookup, this dynamic dispatch, which is something that I sort of explained in the end of the stream last Friday. And I was like, not ideal, not exactly ideal, I don't think. So I redid some things. I switched back so that each color is one function that you call. I think it's easier to use and it is possibly faster, more intuitive, I suppose. Yeah, so I decided to go with that. But when I need to use these colors as values, for instance, for this screen here showing you all the colors, then I can always pull the trick that I was pulling last Friday, but just for the things that I actually need. Let me go over the code to do this. It's not rocket science, but I can explain what's going on. So one thing that I also changed is here on the enumeration, I am enumerating by hand instead of using in the enumeration function. I'm not even sure if I have the enumeration function anymore. Yeah, I think I still have the enumeration function here, but I'm not using it because I think it's more explicit if I have this connection, especially because suppose that maybe you change one of the options to something else, like maybe it's not color, now it's space. Then you would have to make sure that you have every declaration in the right order and everything. And I'm not sure that that's the best scenario. So I think it's better to have this explicitly written by hand so that these numbers match the options over there. But I still have the facility for doing enumerations. And in fact, these things for enumerations and data structures in general are going to be the topic of today. But first, I will explain everything else that is going on. So I think that this probably is new. I put some comments here to say where these numbers came from. And then I put back the L underscore in the beginning of everything, because now that I have one function per color in the design system, one function per kind of space and so forth. Now there are dedicated functions for these things. I don't have as many variables here. I have a bunch of functions, but I don't have as many variables. And therefore, I am not polluting this right pane here where all the variables live. I only have like one right now, which is the current enumeration, because I still have that function to help you create your own enumerations. But I don't have thousands of variables there, because there is no enumeration for colors, they're just different functions. Now, one thing that I'm not sure is if the autocomplete will work. Yeah, so autocomplete will not work because it's across functions, across imports. So that's an unfortunate downside of this decision. But I think that overall it's clearer, and I think it pays off. So I have a function to declare the background color, and I don't have the initialize function anymore, you may have noticed. I just initialized the thing to force you into retina display, but I don't need to initialize anything else because I also did the background thing. I mentioned this like 2 streams ago. I wanted the background to be this way because if the window opens too small for whatever reason, the background overflowing is kind of indication that it didn't fit. So the user would be tempted to increase the window size and see the rest of the effect. But once I had all this, I noticed that there wasn't a lot to do in the initialization thing. So maybe it will come back in the future. But for now, I'm just setting a background color of REAPER gray. and then drawing a rounded rectangle with this color. I don't think anything about the rounded rectangle changed, just the fact that it is here has changed. And Aria says, Boa tarde. Boa tarde, Aria. How is it going? So, since you're just catching up now, what I'm explaining now is how I changed everything after the stream last Friday. I was explaining all the advantages of having this so-called dynamic dispatch, where the colors were values. I decided to not do that, go with the simple thing, just have a bunch of functions. Now I have some variables here to define some spacing things, and then another thing that is new is this print function. What it does is print to the screen. But why do I have it? There is already JSFX drawString. Well, it is because when you're drawing a string, you have to remember to set a bunch of things. And I had those things everywhere where I was printing stuff. You have to remember to change the color, the font size, the position, and then over here, how the text is going to align in the text box, and then the width and the height. So I decided to just, again, improve the Reaper API with something that wraps around the Reaper API. And this way, you have to remember to pass all the arguments from font styles, like the size and the weight and the position of the text in the box and whether it overflows the box or not, and the color and the size of the box. And then you just have to be explicit. Well, this is not the size. This is the position. This is the size. But you have to be explicit about everything when you're printing. So I better just force you into that by having this print function. Then same for this one. So I have now some bold text and some non-bold text, and I have all the pages, by the way. So this is done, and we'll be able to move on to the next interesting thing in this stream. And I suppose that almost everything else about this thing here is uneventful. I'm just looping over the colors, and I said that when you need that sort of color as a value or space as a value, when you need to make something into a value, you can do that on demand, applying exactly the same trick. I have sort of an enumeration thing. I just check. In this case, the enumeration is not fixed. It's this color index variable that I loop over. And I just have a list of all the colors. In this case, the color names, and below here, the color values, and I just call the right function. So this is something that you can do if you need to have colors as values. And that's in fact something that I expect to need in a few contexts besides just this demonstration thing. For instance, in my oscilloscope, I have one color line per channel. The right channel is red, the left channel is blue, and so forth. But if you have like 64 channels, I need to have the colors as values to iterate over the colors. So this is a trick that I can simply pull on that effect where that's needed. But I don't have to pay the price of dynamic dispatch, both in terms of performance as well as in terms of ease of use for everywhere where I want a color. And Aria asks, like when making meters, when you want to have meters of different colors, then you can pull in this trick of using an enumeration of sorts to get you the right color. So you can always change code into values. So this is code, right? It's a function call that you cannot construct artificially, but you can turn that into a value by making an enumeration that calls the right function. So this is, in fact, a reification of the dispatch table if you want some fancy words. Those are the technical terms for these things that I did here. So yeah, that's pretty much all there is to it. I just loop over all the functions and get the colors, and then over here I actually draw the colors. I print the label and I draw the little square with the right color. And that's the story. So the color selectors are done. Let's move on to something else, which is not exactly visual. It's one of those things that we are going to need to do anything interesting with audio, so we better just have a way of doing them. So data structures. And that's what I want to talk about today. as you may know from having watched the previous streams, data structures in JSFX are pretty much just one big array. That's all you have. You have one big array, and you have to be careful about how you index into that array to get and set data. And you have to slice the array yourself. JSFX is just going to give you one big space, and it's not even going to have any facilities to help you find the right thing in there. So we are going to give a bit more structure to the users of our library. And I believe that I put this in the order that we are going to do them. No, let's start with enumerations, then structs, then arrays, then circular buffers. Yes, let's do things in this order. So enumerations we sort of already did, but I want to revisit this because the way this works right now is all enumerations share a single counter. And I don't think that's the best way of doing this. I think that each enumeration should have its own counter. Now, we can always make the user write everything by hand. And I think that makes sense in a context like this, where you have a page variable and you are doing that sort of enumeration. But if you have an enumeration of a different kind that is not related to user input necessarily, you just want a set of variables that don't share the same value. In that case, I think it makes more sense for the counter to be separate, for the counter to be different for each one of them. So how about we create another page for the demonstration here? We'll write some sketch code here on the demonstration and then extract it into the library. Now I wonder if I should put this first or last. I suppose that people will be more interested in the colorful stuff and then in the data structure, so I'll do it like this. And I have to check before I start drawing the pages that I am in one of these 5 pages, because all I had were one of these 5 pages, so I was not checking, it's just drawing. So this background color stuff stays, and then the body and the padding and the title, that all stays. And then this will need to change, and that will need to change. And then from here to the end, all of that is going to change as well. So let's check our page. So if our page is equal to this, or if our page is equal to that or that or that or that, so in any one of those conditions, I will want to run everything in here, which is what draws the color stuff. Let's check if this works. When I go to REAPER and reload this guy, we should see all the pages with the colors, but when I go to data structures, I shouldn't see nothing. Perfect. Then over here, when it says color, I should have something similar to this. So in all those situations, I will have color. Otherwise, if I have page equals data structures, which will be page 5. So if my page is that, then I will have L. Not even sure I will have this title like L underscore. I'll just have this instead. Yeah, there we go. Now the labels here are like how you would find the function for the right color, like L underscore color underscore underscore gray medium underscore underscore 500, for instance. But in the case of data structures, I don't think it even makes sense to have something like that. So yeah, that's why I'm just calling this page data structures. Let's review our changes. I'm not sure I love this indentation. This here is okay, but this is not ideal. I prefer it like this. Usually I work in languages that have an auto-formatting thing, then just follow whatever that does, and you may not like it, but you don't worry about it. But because I have to format by hand, there is no auto-formatter for JSFX. Maybe in the future we'll develop one. But because it doesn't exist, I have to think, how do I want to establish the pattern? How do I want this thing to look? I think I want it to look like that. So we have now a page for data structures. Let's move down here and we'll have something like page equals page. Well, I guess I'm going to change the name of this. Instead of L underscore data structures, I think I'll just have data structures, like so. Now we have all the skeleton for start writing this page. So let's think of a let's think of an enumeration, because that's the first data structure we are going to look at. Enumerations. Let's think of an enumeration that has nothing to do with user input. I guess the first that comes to mind is the one that we developed together in a stream weeks ago. So if you have something like a filter, an equalizer with a filter, then the filter type may be an enumeration. So I think that the way that this is going to work is we are going to have a function, but unfortunately I cannot declare a function inside conditional like this. Oh, and I forgot a question mark. That would come back to bite me. So maybe I guess we can just start writing the thing in the library itself. Not that it matters that much. But anyway, I think we'll need some sort of global variable like this. And I think that we need a start function that will set this back to 0. And then maybe an enumeration type, something like that. And then the way you would use this is, for instance, filter type. Well, first of all, you would need to start the enumeration. So you would call this function to start the enumeration. And maybe not type, just enumeration next. There you go. That's a good name, I think. Arya says, I don't exactly get how this works just yet, but I know this is going to be very useful. Okay, what exactly you don't understand? Do you mean enumerations? Do you mean the concept of the library in general? Do you mean the color stuff? What is it that you don't get exactly? And by the way, did you get my email? I don't think I will be able to stream for the rest of the week. And if you need help to finish what we started, like to change DNS configuration for your website, you can get in touch and we can have a quick call. But I don't think I will be able to stream for hours. So yeah. So enumeration starts and enumeration next. So probably we would have something like a filter type, low pass, and then a high pass. And then a band pass, and then a notch. Something like that. And now check this out over here when I reload this. Our filter types have Well, they should have different values, but they don't. They are all zeros. So something is weird and wrong. Okay, so the enumeration bit, but I guess keep going and I'll ask questions in the end. Okay, so the purpose of the enumeration is just to have a name. In effect, what I want is just to have a name that I can refer to like this. But I want to be able to say, is the page this page? And is the filter type that filter type? So eventually I will have, from somewhere, I will have a variable that will be filtered that will be one of these. I can even say something like this. Maybe I'll not write it as a comment. I'll do something like this, right? So for some reason, I select this type of filter. Maybe it is because the user selected that kind of filter, but maybe it is because I am doing some sort of effect like a compressor and I'm filtering the sidechain before I put it on the RMS detector, something like that. And I decide which kind of filter I need. Then in that case, I can just assign it to a variable. And then in the definition of the filter, so I will have something like a filter and I can have a filter type or maybe just type. And then in the definition of that function, I can check, is my type equal to filter type notch? If so, then compute the coefficients in a certain way. And it's exactly what we did before, but now I'm providing you a pattern. I'm establishing how you should create enumerations. I'm teaching you how to create enumerations effectively using this library. So you can see that the code is going to be super simple as soon as we get it working. So the code is super simple, but what is more important is that now we have an agreed upon way of doing enumerations, and everyone will do enumerations using this same technique. Yeah. Enumeration is probably one of the simplest and most boring data types because it is just a list of numbers. But for some reason, not even the most simple and boring stuff I can seem to get right. Oh, it is because I am not in the right section. And here we are. So now the filter types are different numbers. Now, of course, the numbers are not interesting. What's interesting is the fact that I can do comparisons like the ones I showed you. So that's the point of an enumeration. Super simple stuff. And I will create another one because I want to exercise the fact that the enumerations are going to start with the number. I suppose I want to make it the number -1 so that the first enumeration type will be 0. No, I'm going to leave it as 0 so that the first enumeration type will be 1, or the first enumeration number. So let's think of another thing that could be an enumeration. We already have the pages. They are an enumeration. We have the filter types. They are an enumeration. I definitely want to have another example. So what would be... Oh, so maybe in a compressor. So in a compressor, let me put reacomp here. Recomp. Yeah, so detector input can be the main input or the auxiliary input or some feedback. So let's have an enumeration for that. So that will be the compressor detector input. And we'll say that one is like the main, the other will be side chain, and another will be feedback. And we don't need a fourth one. And then I can remove this, reload that, go to the fourth page. And here we are. So where is it? It's not there. Let's do a full compile reset and try again. Yeah, compressors. Now the different types are there. Just different numbers. Nothing major, nothing too interesting. You're saying that channels can be enumerations. Yes, they can, especially if you want to have an effect that is constrained to be stereo, for instance. Then you definitely you can, if you want, have an enumeration for channels. I don't like that style. I prefer to loop over channels, and if I can, make my things multi-channel. Yeah, it is what it is. Now, this is working in the sense that this simple implementation here implements the concept of enumeration, but I'm not really sure that I have a good way of showing this. I don't know exactly how I'm going to present this to the user. I will worry about this at some other point. Maybe what I will have is something like this in text form in the thing here, so it will show a snippet of code, but I'm not really in love with that, because if I want to show snippets of code, I better just send you to the code, which will be the source of truth anyway. So maybe instead what I will have is something like, I will have something like filter type equals like high pass. So what I'm getting at here is maybe I will try to teach you how to use the thing, but maybe I will just have a test, sort of an automated test. So maybe I declare all the enumerations and then I have some sort of automated test. And for this one, it will be so simple that it's ridiculous, but I will have it anyway. So maybe I will have something that draws on the screen. And automated tests are computer programs that test computer programs. So the computer program is going to pretend that it is a programmer. It's going to pretend that it is a user clicking around. It's going to pretend that it's using the programs in some way. So in this case, the library. It's going to pretend that it's using the library. And it's going to give you information, whether the thing worked or not. So we could, for instance, have something like this, where it is absolutely ridiculous, but we could have something like this. And I don't think we need to make it bold. I think that regular is good enough, and extra small is okay, and horizontal left and vertical top, and then this location needs to be different. Let's go in this part. I think that I want to borrow this snippet. No, not quite that one. Let me try again. Yeah, probably more like this. Then of course I need to get a hold of these computations for... In particular, I'm interested in this line, so I guess I'm going to borrow this line. And then I will collapse this section of 4 colors again, so it's not in the way. And over here, I have my X coordinate, which will be the body padding, and the Y coordinate can be the body padding plus the title height plus the body gap and all of that. Now let's see what this looks like. So you see, it's not awesome, but it is showing that the data structures work. It is a test. It's showing that the data structures are there. It's working. So for now, that's going to be all. And it's not super, super, super interesting, but it's something. Let's go to the next data structure, a struct. So an enumeration is just a way of differentiating between some names. We have different names for things like filter types, and we want to differentiate between the names. A struct is the first data structure that is going to put put multiple pieces of data together in the same box. So we'll have a box with different parts. Usually variables have a single value. In JSFX, values are numbers, so variables have only one number. But we want to sometimes have multiple values. And that will come in handy when we are developing the next data structures. But let's think of a struct that is just two values put together. For instance, a coordinate. We are working with coordinates all over, right? And when we are working with a coordinate, we have to give it the y, the x and the y coordinate. Or in some cases, the width and the height, which amounts to the same if you think of a width and a height as determining a rectangle or as a vector. Doesn't really matter. In any case, you have a coordinate. So a coordinate is a struct with two pieces of data, x and y. And right now, we are creating a bunch of them just by hand, just passing two values. But we could have a struct with x and y, and that would be a single value that we could pass around. Now, again, JSFX don't have that sort of feature, so we'll have to create this. But let's start from the example. So let's think about how we want to use this. I think that I would like to say something similar to the enumeration thing. So I think I would like to say something like struct start. And probably I would need to assign it to something. And because this is like a data structure, I am going to have something like coordinate. And this C will be capitalized to mean that this is a data structure. In other languages, capitalized words or variables would be for things like classes, which I guess is sort of similar in principle. Then let's say that we would have something like one of the fields will be, well, I guess now here we have to say what is the name of the field. Let me take notes. And then the size of the value that we store there. And maybe the name of the field will be an enumeration. So check this out. Yeah, I guess I can have the name as the return value of the thing. But I do need the size. In this case, the size is 1. We just need one number. Yeah, but in other cases, we will need more space to store. So let's say that this is how you use the struct. You have a coordinate, which is a struct, and then a coordinate x and a coordinate y. I think that this is nice to use. You just have to say the sizes of stuff. And then you get back. Effectively, this is a struct. Sorry, this x and y are an enumeration. And then to use this, let's say that I want to have a coordinate for, I don't know, a label position is an L struct new. So maybe this will not be start, it will be something like define. Yeah. Yeah, and then I have to say what is the struct that I want to instantiate. And then I can do something like struct get. And then I have to pass the struct itself, the position. And there you go. And to set, I will need to pass the struct, the position, and the value to put there. Yeah, it has good shape. I haven't really thought too much about how I wanted to have this definition, so I'm sort of winging it, but I think that this is going to work. We'll see. But first, I want to make sure that I rename the thing that I want to rename. So instead of start, it will be define. And of course, when I do that change, I need to do it here as well. So there you go. Now it is called enumeration define. And then enumeration next. Let's go to the Wikipedia article for enumerations real quick. Maybe they have a term of art for this. Enumeration is a complete ordered listing of all the items in a collection. Yeah, I'm more interested in the computer science spin to the term. So it seems like item is a keyword I could use. Let's see what they have for enumerations in Java. What is the terminology that they use over there? Finding the right name is super important for people to translate what they already know about other languages into what we are doing. Because JSFX is no one's first language. So we want to, the idea is to translate as well as we can. They just talk about the collective thing, the enumeration itself, but not about the elements in there. Guess feud is the best word I can get. No. Feud is something else. Well, an enumeration is a special Java type used to define a collection of constants. So I think I'll call the thing the constant. So instead of next, I will have constant. I'm not in love with this, but it is what it is. Maybe I will put 2 underscores. Yeah, I think that makes more sense. And then over here, I will have L underscore enumeration and an underscore index. Yeah, whatever. This name is not super important because this name is internal. Let's go to L underscore enumeration. And everywhere where we have define, we'll leave define, yeah. And then constant instead of next. Oh, but it's super important that I put the extra underscores in there. And the beauty of this is that if I did everything correctly, we can reload the thing in Reaper and we should still see the check mark because of the automated test. Okay, it's not much, but it's there. Let's commit what we did. So it was mostly just renaming stuff. Yeah, and then we have the struct, which we started. We have an example of how we want the thing to look like, but we have not really implemented the thing. So let's do that. Now, I started with enumerations because I thought I would not use, because I thought they would be simpler, but I didn't expect to actually use enumerations for anything else, but it seems like I'm going to start using enumerations right now to define structs. And I'm sure that I will need structs to define arrays, and I think I will need arrays to define circular buffers. So that's why I have them in this order. So yeah, data structures, enumerations, that's that. Now let's have a function called struct define. And what I need to do to start a struct is, well, we have to start talking about memory. So remember how there is just one big chunk of memory. It comes with 8 million slots, and you can ask for, I guess, 120 million if you need. It's just a big array of memory positions. And I want my coordinates. So there are different ways of doing this, but I want my structs to be able to hold stuff with different sizes. Or do I need that? I may not even need that. Yeah, I'm thinking about arrays, and arrays will have more slots in there. But I could always just define an array as allocating some other kind of memory. Yes, so never mind the array for now. We'll cross that bridge in 1 minute. How do I want the memory to be laid out? Well, if I am going to store multiple things in a single variable, I have to use the memory. I have to use the 8 million slots in some way. But I'm not sure about how I'm going to do that. Let's have the skeleton for all the functions we are going to define. So I know that I need struct define, I know that I need field, and I know that I want multiple underscores in there. So let me replace all occurrences of struct with struct underscore underscore. Yeah. Yeah, I think that this is going to play out very nicely, but let's continue. So struct new and set and get. And I know that in the definition and the field, I may not need any arguments, but for this one, I will need the struct. I need you to give me what is the struct that you want me to allocate. And then for set and get, I need the struct. Well, I guess this is the struct definition. Or maybe even the capital S struct. And this is the lowercase s struct. And this is going to be the field. Maybe a capital F field. And this last one is the value that you want me to set. And over here, I will need a struct and I will need the field. So that's the skeleton, the so-called signature of the functions that we need to define. Now let's think about how we want to actually do this. I think that what I'm going to do is I will need to start thinking about how I'm going to use the memory. So how about we have a variable that will be up top here because most data structures will depend on the memory. So let's call this L underscore memory index that will start at 0. And then let's have a simple memory allocator. LMemoryAllocate. That will be a function that will receive a certain size. How much memory do you want to allocate? And let's say that my memory allocation will increase the index by that size. But I also want to return the current index. So let's have a local variable. LMemoryIndex. And then in here, because this variable is local, doesn't leak to the global context, I don't need the L underscore. I don't need to namespace the local variables because they're not going to clash. I could have multiple functions with the same local variable and they would be distinct. But the main point is that I want my memory index to be returned. So when I allocate, I bump up that memory index pointer, but I return to you what is the address that you could use to have this certain size. And I also want to have a function for LMemoryEnd. And what I want this function to do is to manage the memory for JSFX. Tell REAPER that I don't need more memory. And this is sort of an optimization. It's just saying, it's just notifying REAPER to say, I don't need more memory than this. So if you want to allocate the extra memory to do something else, it's up to you. So I can say that I'm free from up to index, actually. So let's think this through. So if I want to allocate like 10 slots, this number is going to be 10, and that is my first free index. So I think that's all I have to do, at least for now. So in effect, I expect you to define the things you're going to need in terms of memory. So all your structs, all your enumerations, even though enumerations are not really using memory, but I expect you to define all your data structures in the init block, or at worst in the slider block, but not in the GFX block or in the block or in the sample block. So in other words, I want you to allocate all your memory up front. I don't want you to be allocating and deallocating stuff in the middle of execution. So in other words, I don't want you to run this kind of code in this position, and we'll switch this to somewhere else. But first, let's see if all of this makes sense. So I think I need to write some tests for my memory allocator. So how about I take a step back and I comment all of this out. And with that, I think that everything that I have on the screen is working and the tests are passing. So let's write some tests for the memory allocator. And it's tests, but it's also sort of documentation. I expect people to dive into this JSFX for sort of documentation, executable documentation of how things should work. So let's go to the init block for writing the memory allocation stuff, for allocating some memory for real. But now that I'm looking at this, maybe I want to have the enumeration stuff. Yeah, I think I will use the enumeration stuff here. Doesn't hurt. Works exactly the same, and it's documenting how enumerations should work. Now, my concern that if you reorder something in here, you will have to reorder something in there. Well, that is just the nature of the game, I suppose. Now let's see if this is still working. And the test is super simple. If I have no compilation errors, for instance, then the thing's passing. But let's see. So there is a problem in line 49 in the library, which is this line. Oh, I don't think I can have functions with no body. So for now, I will comment everything in here. So yeah, colors are not fully working. And they are 1 off. Okay, I understand the issue. My enumerations start at 1, but this starts at 0. So to make this work, I will start my enumerations at -1. So now it's back to a working state. Yeah, let's commit all these fixes. And maybe we could also have an LMemory start or begin. Begin or start? I can never be sure. I guess it's start and finish and begin and end. Don't have any other occurrences of start, right? Okay, so I'll have something that is begin. And it's super simple, right? It's just initializing, but I am going to give you the option to initialize with a certain number. I'll call this the memory index. Why? Because you may be using my library with some other library, and in that case, the other library may have its own opinions about how to allocate stuff. So you can just either use my library first or their library first. If you use my library first, then at the end, I'm going to give you the index. I'm going to return to you the index. When you are done using my library, you can call LMemoryEnd, and you're going to get back the index that you have to use to start allocating for whatever else you're going to do with someone else's library. Alternatively, if you want to use my library later, you can use LMemoryBegin to set the index. Yeah, I'm not sure what will happen if you call freeMbuff and then you do some more stuff and you call freeMbuff again. I'm not sure what's going to happen in that case, but I'll just hope for the best. I will hope that you'll be able to do this. Now, since most functions are going to be multiple lines, I'll make these multiple lines as well. But I want the LMemoryBegin to have an optional argument. That's what I would like to happen. So let's see what happens when I do just this. I'm not giving an argument. So is it going to do the JSFX thing where if you don't pass, if a variable doesn't exist, it's 0? Is the memory index going to be 0? Let's see. Right now, I just have begin in my code, and I never allocate any memory. So by the end, LMemoryIndex should be 0, and it shouldn't throw any compiler errors or anything. Yeah, it is 0, and it didn't throw any compiler errors. Alternatively, if I have a begin with a certain number, like 100 or 1008, then it changes to that. So yes, now we learned that you can sort of hack your way into optional variables. Sort of knew that this was the case because I saw it somewhere, but I wasn't sure because I haven't tested myself. It seems to work. Yeah, but in theory, I think that you should call my library last to make sure that this is going to work. But it's something that I can document. So LMemoryBegin, and at the end of this block, I'll have an end. I like this parallel, how it shows you that this is the section where I am allocating memory. Or in other words, that I'm allocating all my data structures even. Oh, and because I have this define thing, I could have something like begin and end for enumerations, but I don't really need that, so I won't have it. So now let's find our struct that is defined below, and even the other enumerations, right? Yes, all of these things, they should happen in the init block. And it is unfortunate that you have this separation. I usually like my things to be co-located, but in JSFX, because of the nature of the init block versus the GFX block, you are forced into this separation. So you have to define all your things in the init block, and then you use them somewhere else. And this is similar again to languages like C. So enumeration define, enumeration define, enumeration define, enumeration constant. And then you can just use enumerations like I am using here. And I will also push up my comment. Right now it's commented out, but the definition of structs, I'll also have them up there because that's ultimately where it needs to live. So right now I just moved things around. I don't expect anything to break, but I'll test anyway. Yeah, I still see a check mark. Let's go to the definition of structs, because for structs we'll need to allocate some memory. But now, oh yeah, let's write the test for memory allocation. Right now we have begin and end, or yeah, begin and end, but we are not allocating any memory. So let's allocate some memory, shall we? So call this the memory chunk, and it will be 20 positions. And in my memory chunk, well, first of all, if I just do this, I expect my LMemoryIndex to now be 20. It is. But next, let's actually use this memory chunk. Well, I have to allocate it here, but I don't have to use it there. I can use it way below, down here. So the same way that I'm doing something to a certain enumeration, I will do something to the memory chunk. And I allocated 20 spots, so I can go from 0 to 19. Let's start with 0. Let me write a script real quick. So from numbers starting at 0 up to 19. To write something like this, I will do a for loop constant I of an array which is new array. of 20 positions. Let me get a hold of the keys in that array and console log a string containing I. Yeah, that much works. Then I will need memory chunk at that position. And let's say that what is in there will be like 1,000 plus I. And a semicolon at the end. Now, I'm putting stuff there. I will write another one of these tests. Oh, and I think there is a cool trick that I can play. So when I write something using this, the cursor will be at the end of whatever this is written. So if I just use JSFX and JSFX I can just write my check marks or my poops right next to one another. And what I want to do with my memory is I want to check something like this is equal to something like that. Now, when I run this, I expect to see two check marks, one next to the other. There you go. Now, it's of course not a perfect automated test situation. It's not bad. Let's commit what we did. So we allocated some memory. And I'm starting to see this repetition that I dislike. So maybe there is something that I can do about it. Let's go into the init block again. And after the memory allocation, I will define a function that is called test that receives just I guess I will receive the actual and the expected. Well, maybe not, because that will force me into equality things, and maybe I will want to have something else like less than. So instead of having something like that, I'll have something like assert value. And then I will do something similar to what we did here, except that we replace this with value. Maybe I'll call it Boolean. No, I'll assert. Yeah, I guess I'll call it a Boolean. Yeah. Maybe I could have like a test description. Yeah, we'll see. First, I'll extract what I started extracting. So I will assert. Well, I need to put the JSFX X and Y in the right places to begin with. So let's do that. Okay, so this is me setting up the thing, and then I can assert that, and then I can remove all of this. And then down here, I can assert this, and I can remove all of that. And maybe let's do something more interesting, like the 9th position. Not majorly interesting, but more interesting nevertheless. Let's run this. And still the same 2 check marks. Perfect. I think I'll separate this setup from the rest of the code. And now that the test looks like this, it is absolutely ridiculous, but it doesn't hurt to be there. Fun stuff. Yeah, cleans up a lot of things, and I like the way that this reads. To go to the data structures thing, you just set something up for the position and then you start writing. We could have labels for the assertions. That could be fun. But let's not do it now. Instead, let's think about what else we want to test. So we tested memory allocation. We didn't really test this part, but there isn't much we can do to test it. We know it will work as long as you call LMemoryEnd. Now I have a memory allocation thing, and very importantly, this memory index does not show up in this right side pane. Let's do a full compile reset and look for memory index. We have a memory chunk, but not memory index, because it's local. Next, I think that we finally have enough infrastructure to do structs. So what do I need to do when I start a struct, when I define a struct? Well, I think that I just allocate some memory and return it to you. What do I want the memory to end up looking? I have something like coordinate. Yeah, let's uncomment this and start thinking about how I want the memory to look like when I have this working. So I expect coordinate to be someplace in memory, let's say like position 24, that will map to the number of fields, 2 fields, X and Y. Then I expect coordinate X to be more like a struct. So for instance, 0. And I expect coordinate Y to be 1. So internally, this will be not a struct, this will be an enumeration. Now, when I define an instance of this struct, I expect something like label position to be equal to another region in memory, like say like 315. And this place in memory will point at a chunk of memory that reads like the actual coordinate. So 10 and 0, for instance. And then, yeah, it's just going to work out, isn't it? Because when I do something like label position at coordinate X, I will be reading position 315. at position 0. So the number 10. Yeah. So what I need, the pieces that I need are a struct for the fields. I keep saying struct. I need an enumeration for the fields, and I need one bit, just not one bit. I need one position in memory to allocate the size of this. And I need the size of this because when I do new, I need to know how many spaces to allocate for this. Awesome. I think I nailed this. At least the design seems solid to me. We'll see when I start implementing it. So when I say struct define, I need to allocate a piece of one chunk of memory. So I'll call this like struct index. It will start at 0. Then when I define, I will say struct index equals LMemoryAllocate. And I just need one position. So allocate that position. And that is also what I return. So I'll leave this statement for last, but I also need to start an enumeration, which will be the fields. So I will also say enumeration define. Now, when I create a new field, that is just creating another one of these enumerations. So I'll just call enumeration constant. But I need to remember to increase the number here. So this will start with 0. Lstruct index will start with 0. So I can just go to that position in memory. I think I prefer to write it like this. So I'll go to that position in memory and increment 1. I'm thinking whether I want to zero out this thing or not. I believe that REAPER will guarantee that to begin with the thing will be zeroed out, but let's see. All memory and variables are 0 on load, so I will not worry too much about initialization. I will just expect everything to be zeros. So what I do to start the definition of a struct is I start the definition of the enumeration, which will be the fields, and I start an index, which is a new memory position that I'm allocating. Oh, hey Bo, great to have you here. I answered your email. Took me a while. Sorry about that, but I answered. And it seems like what you are doing is completely new in the whole moving average. Really interested, but I'm not sure I understand how I can help yet. So I just asked a bunch of questions. In any case, what did you miss? Well, I finished the screen that shows you all the different colors. And I did that off stream. In the beginning of this stream, I just glanced over what I did, but it's nothing major. Just finished that, and I decided to go with the original implementation in which each color is just a function that you call. So that's that. And now we are working in data structures. First, we have something to allocate memory. So that big chunk of memory, we now have some structure of how we are using that. Then we did enumerations, which are things like different kinds of filters, for instance. It's just a different name that you want to be able to differentiate. Just a name. And then we are now working on structs, which are these data structures that put together two pieces of data. And the example that we are going for here is coordinates in the plane. So a coordinate is a single value, but it has an x and y, I want to say sub-values. So it's like one box. The coordinate is a variable that's one box, but we want to be able to subdivide this box. And we have to use the memory for that. So that's what we are implementing right now. Okay. Let's continue. So when defining a struct, you just allocate one chunk, one slot in memory, and you start an enumeration. The enumeration is going to be the different fields that you can get from or set to, and the place in memory is the place where we are going to store how many slots this struct has. And then when you want to define a new field, you are going to increment the number of slots. Maybe we could call this, instead of index, no, this really is the index. Yeah, let's call this the index. And at position 0, because we only have one position anyway, but at position 0, we add 1, and we call the enumeration function that will add 1 to the enumeration index, so it is going to keep increasing this number. Oh, and it's a good thing that we put this as -1 to begin with, because this plays out nicely with the indexing that we are about to do. So to create a struct, to actually create one of these places, we have a struct definition, capital S, and what we're going to do is to allocate some memory in there. So we are going to call the malloc function, the allocate function. We called it allocate. So memory allocate, and we are going to allocate struct 0. So for instance, if struct is, for instance, in this case, it will be the number 2, we are allocating 2 slots of memory. That's what we need to do to say new of a data structure. Now to set something in there, we have a struct and we index into the field and we set the value in there. And to get, we do this. Now these things are so short that I think I can get away with like doing them in one line. Yeah, but I will not. And same for this implementation, by the way. I think I will do this in multiple lines. Right? Do I have any other occurrences of something like this where I'm doing everything in one line? Well, I guess I have, but these are just so simple. They are just values and they're part of the design system and they're super long anyway, so I guess I'll leave them as they are. And over here, I don't have anything like that. Okay, so let's review this. All right, I think that this makes sense. Now let's see if this is going to work. Now, the definition of the coordinate is the definition of the structure. That needs to come in this init block where we do memory allocation. And I'm going to pull out these comments because they are going to be unnecessary in a moment. And the definition of the label position also needs to happen when we are doing initialization because we need to allocate some memory for that. But the setting and the getting doesn't need to be here. So it won't be here. Yeah, right. And then let's move down to where we are testing stuff. So we are testing memory allocation. And then we'll do the setting and getting. But I think that this is out of order, isn't it? We are doing first memory allocation. And this is not the first thing we are testing. So let's do it the other way around. Yeah, we're testing memory allocation first. Then we are testing the enumerations. And then we are testing structs. So I set the label position to a certain number, and then I assert that whatever we get back is the number 10. Yay, one more tick mark. Okay, that was interesting. It was not trivial. That was a fun thing to do. Especially because I wasn't thinking. Sometimes I find these interesting problems and I keep thinking about them and I come up with the solution in my head. And then when I start streaming and implementing stuff, it's like, oh yeah, I sort of know what I'm doing. Bam, bam, bam. But this time I didn't really think about the problem thoroughly. So I'm kind of winging it. And I think that I landed on something that I like. But who knows? Maybe I will do something like I did on Friday when I finished the stream and I was like, don't really like where I'm going. Backtrack. We'll see. For one thing, do I want to have set functions or do I want to let the user interface with the struct using this notation? So yeah, we have two options. We can do it like this. This is a set and a get, or I can do it like that, a set and a get. Now this is lower level and shorter. And in theory, we will not need to have much more in the code besides this. So maybe we don't need set and get because we kind of already have a notation for setting and getting stuff. It's this notation, and this is longer and more verbose. So maybe we don't need that. Because we were so clever about the definition of stuff that just worked out. Yeah, so I guess I can just literally take this part, put it there, and use it like so. And this is kind of conflating the notation for arrays and the notation for structs. But this is also what happens in languages like JavaScript. So people may be used to that already and may even appreciate this similarity. So let's see if it works, but it should. See no reason why it wouldn't. Yeah, it's still working. So yeah, I think I prefer it like this. Another thing is, could I allocate more of these coordinates and then use the coordinates? Can I maybe have like a coordinate as a first class thing in my library instead of... I like this example so much that I may want to make it part of the library because we have so many library functions that depend on coordinates. What would that look like? Well, things like the design system won't change at all, but they're just sizes and colors. But, so let's see. Font size and style will not change. Background color will not change. But print could change and rounded rectangle could change. What we would change here is the x and y, the width and the height. The x and y, the width and the height. We could allocate memory for a coordinate and use that. Now, that would make some things shorter, but I think it's a bad idea because we want things like the rounded rectangle field to have the same signature as the rectangle function from REAPER. Maybe not, but that's what we were going for to begin with. Yeah, and same for the print stuff. Yeah, I think I'll keep it simple and not have a struct for this. But you can create your own structs when you need. So yeah, struct. Check, we did structs. Now, we have arrays and circular buffers. But I think I will wrap it up, actually. Yeah, I will leave arrays and circular buffers for later. In fact, I will not be able to stream for the rest of the week, probably. I don't know. In any case, what you can do is just subscribe and hit that notification bell, and you will know when I will stream again. But I have visits coming over, and I don't think I will have the time to actually stream, so I don't know. But in any case, I think we did some interesting progress. In particular, I really like what we are doing with the struct thing. It's so simple. It's just one place in memory, but it works out so nice in the definition of the struct. Like so. Yeah. Very cool stuff there. Like it. I like it. Yeah. Okay, so that's it for now. Thanks for subscribing, for going to PayPal and Patreon and showing your support, and for being here with me every day. I see you when I see you. The visit is going to be here for 1 month. I don't know how much I will be able to stream. See you when I see you. And when we do, when I see you again, we'll talk about arrays and circular buffers. And that will be a lot of fun. But for now, thanks for checking in and have a good one. Bye.